Hello, my name is Abdullah Shabani, and for our project we built an interface that allows the users to explore live stream data that has location information. The idea is to allow users to explore geotagged data streams using the live programming environment and an interactive map and interactive visualization. Next, my partner Thamir will explain how it was implemented.
Now we present our system's architecture. We develop our system using the client-server paradigm. On the server side, we implemented our own custom-made web server, which is responsible for serving the web content to the clients and also is responsible for connecting to external data streaming APIs such as Twitter Streaming API and buffer the streaming data. On the client side, we have implemented live programming support, map-based visualization, chart-based visualization, a code editor, and a stream control widget. An important question that we need to answer is, what is live programming? We define live programming as the process of writing computer programs while having continuous perceptual feedback of the program's execution. Now we will give an overview of the user interface. Our platform's user interface consists of four major components. On the top left, we have the stream control widget. This widget will allow users to select the desired dataset, start and stop streams, control the stream arrival rate, and the stream window size. A progress bar will provide a visual feedback of the progress of the stream. On the bottom left, we have our code editor where users can type in programming code. In a live programming environment, the code will be executed automatically. On the top right of the interface, we have the chart area. The chart area will provide statistical aggregation of the data in the window using a bar chart visualization. In the bottom right area, we have our map-based visualization, which will allow users to visualize the location of the data tuples on the map. In the baseline interface, we have an additional component, which is a button. Users will have to click on this button to compile and run the written code. Now we will demonstrate our system. We will use the dataset of 911 calls of the city of Seattle. We want to compare the frequency of calls related to medical responses to other calls. To do that, first we need to select the dataset. Once the dataset is selected, two buttons will appear to allow us to start the stream and stop the stream. We will start the stream by clicking on Start Stream button. The default arrival rate of the stream is 1 tuple per second. We can increase that by changing this parameter. To categorize these calls, we can use the categorize command to specify the categories we want. For example, we will use the keyword medic to choose the categories of medical responses. Since this is a live programming environment, the screen will automatically update itself and give continuous feedback. We can see that the medic category is not very frequent. We can use the map to see what other kind of calls that are falling into the uncategorized bin. For example, we found that this call corresponds to the aid response. Let's add the aid category to the desired set of categories. Now we can see that the aid category has a much higher frequency than the medic category.
For our evaluations, we sat down with students with different programming backgrounds and had them perform the tasks. The experimentation was done with a baseline of our platform, which was only missing the live programming aspect, and the original platform with the live programming. All the participants tried both the platforms but in different order. We had 6 tasks in total and 3 datasets, where the users were able to test the data. All the users were able to complete all the tasks. After the first 3 tasks, the users were asked to rate the platform. At the end of the 6th task, the users were asked compare the two environments and choose which one they liked more. Almost all the users agreed that the live environment was better than the baseline in every way. In the end of our study, we found that having a live environment made the process of explaining the data much easier and allowed the users to explore the data, instead of simply looking for the data where they were asked for. This was one of the main reasons why completion time was not included in the study. Almost all the users went out during their tasks and explored the possibilities and patterns in the data, which made some tasks longer than others. We found that such a tool helps and simplifies the exploration process. As a GIS student mentioned, what usually takes me a long time to perform, I was able to do in seconds. And that is our project. Thanks for watching.